In this problem, we're given a string S that has the letters A, B, C, or a question mark. And in this case, we want to find the number of A, B, C segments that are possible in all possible strings that we can create. So what does this mean? So every question mark can be replaced with either an A, a B, or a C. And for all possible strings, we want to sum up the number of subsequences that are A, B, and C. And this subsequence does not have to be back to back. So if you look at this string, one valid sequence would be this A, this B, or this C. And that would be counted as 1 to the total number of subsequences of A, B, C. One more would be A, B, C, and the last one would be A, B, C. So this would account for three subsequences of A, B, and C. So yeah, again, due to an audio issue, it cut out. So I'll just go over the logic. So there are 4 cases. The first case, actually, yeah, let me just say one thing first. What we can do is, since we know that for every subsequence, B is always at the center. So if we find a B, for there to be a subsequence, an A has to be on the left and a C has to be on the right. So what we can do is we can iterate through the string, find all the possible B's, and then at that point calculate how many A, B, C subsegments we can make with this B at the center. Okay, so the first one is if there's only if there are no question marks. If you look at the A's on the left and the B's and the C's on the right. So here we can make A, B, C, A, B, C, A, B, C, and A, B, C. So the answer is 4. So it's essentially the amount of A's on the left times the amount of C's on the right. So 2 times 2 is 4. Now here, what if there's a question mark on the left and the right? Okay, so first thing we notice is that this question mark has to be a C, right? Because if it's A, B, C and there's nothing else afterwards, this has to be a C. So we fix this to be a C. Now this can, so the 2 possibilities would be A, B, C and A, B, C. That's right, but the answer turned out to be 6. Why is this? So let's say we fix this as A and this is C. So we get A, B, C. Then this can either be A, B, or C, and there are 3 possibilities. So therefore, this subsequence of A, B, and C occurs 3 times. When this is A, when this is B, and when this is C. Using the same logic, if we fix this as A, so this subsequence of A, B, C occurs in the strings where this is A, this is B, and this is C. So it's 6. And the same logic applies for both. So in essence, each time we come across a character that could be a B, we find that we look at all these 4 possible cases and then we sum them all up, and that is the amount of A, B, C subsequences we can make with that B at the center. And then if we sum it all up for all the B's in S, that will be the total number of A, B, C subsequences in a string. So yeah, so the first thing, you'd read an N, you'd read an S, and then you would keep track of the number of A and C's and the amount of question marks. So initially, since we start over here, all the A's, C's, and question marks will be to our right. So that's why we first go through all the strings, and then we increment our A, if right A if we see an A, we increment the C's to our right if we see a C, and we increment the question marks to our right if we see a question mark. So then what we do is we go through the string and we say, okay, if the character we currently see is an A, we take it from our right. Why is that? So if we look at this, right, A, C, question mark, B, C, we start prior to the A at the very start. So now, since we're starting this for loop, we move on to the A. And now currently, since we're on this A, there are no A's to our right. So that's why we have to subtract 1, because if we're currently at an element, that is no longer to the right. So yeah, we just check if the current element is an A. If it is, then we take that off from the number of A's to our right, and the same for C's and question marks. Now we check if the current character we're on can be a B. So that means it's either a B or it's a question mark, because a question mark can be a B. So then we look at the four cases. We find the number of A's on the left, the number of C's on the right, and then we mod that because we don't want a overflow, and then we times that by 3 to the power of the number of available question marks. Why is that, right? So let's say we're here, we can so we times 1 by 1 because 1A to the left, there is 1C to the right, and then it's 3 to the power of 2 because there are two question marks. Yeah, because this can now be, so this subsequence of A, B, C can occur when this is A, this is B, this is C, or when this is A, this is B, this is C, and that would be 3 to the power of 2. So that's why we care of the number of available question marks we have. Now, if we use a question mark and a C, that means we take away one of the available question marks and we use that to be, in this case, an A. So over here, let's say we're looking at this question mark and this C. For this to be a valid subsequence, this question mark has to be an A. So we essentially force this to be an A, and hence the number of available question mark goes down by 1 because we are forcing one of them to be A. So therefore, it'll be the number of available question marks, which will be the amount of question marks to the left and right of our current character, and then minus 1 because we're using one of them to be A. And the same logic here, except we're using one of the question marks to add as a C. Now, if they're both question marks, that essentially means we are taking away two available question marks over here, and we're forcing one of them to be A and one of them to be C, right? And if that's the case, then the number of available question mark goes down by 2. So therefore, it would be 3 to the power of the number of question marks on the right and the left minus 2. And then, as usual, we just times the number of question marks on the right times the number of question marks on the left, and then we times that by 3 to the power of this. And then we just make sure to mod properly. I'm not sure if it matters, but I implemented the power functions such that it can be done in log of n time, and that I think would matter because the time limit is 1 second per test. And then once we take into account all these four cases, then we just move on to the next character, which means we would add the current character to the left. And so that means if it's an A, we would increase LA, if it's a C, we would increase LC, and if it's a question mark, we would increase LQ. And then we just go through the whole string, and then at the very end, we just output answer. And this is a valid answer. So voila.